So I'm going to go ahead and record what I'm doing here on this screen. It'll record your shared screen. So I'm sharing only one of my monitors right now. Everything that happens on there, it will record, and it will also record my voice. And I'm using those to put together some training videos for a bunch of CAD things currently. And that list is growing as we add more videos and as more topics come up. So we're going to be doing corridors right now, and this kind of builds on what we've done before in creating alignments and creating profiles. So I'm going to be operating under the assumption today that we have an existing surface, which I've highlighted here. I just made up an existing surface. Obviously, that isn't real. But that existing surface is going to come from Survey. And this alignment, I just kind of created something that has a few little zigs and zags, so we have a little more fun than just drawing a straight line. But that alignment, that's already been set, that we're working with today, and we already know how to cut profiles, so we don't need to worry about that. So these profiles that I've cut over here, I'm assuming that everybody already knows how to do that stuff. So now today we're going to be focusing mostly on the corridor work. First though, I'm going to start, so this is just so you guys can see the existing surface I created. Just drew some feature lines, assigned some random elevations to it. That'd be pretty cool if that was real, but I'm not thinking that is a thing that can actually happen. So I created this existing surface, and then in addition to that, just creating it, I created a project folder for this work for data shortcuts and created a data shortcut for that surface. So that's something that's going to be important for a lot of the work we're doing between these files, because they all need to talk to each other dynamically. So your tool space, there's a few different ways you can open it. The easiest way, if you got your ribbon, you go to the Home tab. Right over here, the top left thing is your tool space. So sorry, I've got two monitors, by the way, and I like to have all my secondary stuff on my non-primary monitor. So if I'm ever talking about something and it's not on my screen, just remind me to drag it over onto the screen so you can actually see what I'm talking about. Sometimes I forget when I'm doing presentations. So to create data shortcuts, this little bottom section right here, these two, first off, there's 4 tabs over here: Prospector, Settings, Survey, and Toolbox. The Prospector tab is where you're going to do your work in your drawing mostly, and then the Settings tab has a bunch of stuff like styles and all that. We're not going to get into any of that today. Everything we're going to be doing today is going to be within the Prospector tab. So this data shortcuts section right here is kind of like your section for your overall project data shortcuts. So anything that is associated with that data shortcut project folder that's global, it goes into this data shortcuts area. And all this other stuff that's kind of duplicated, like you see there's a surface down here in data shortcuts, there's a surface up here in this section. This is all related to the active drawing, or if you're in master view, a few different little things change, but we're in the active drawing view right now, so we see what's in the active drawing, which is our surf E. And so this shows you what surfaces are in this drawing, and if something is data shortcutted in, it will have this little arrow next to it. So to create a data shortcut, you just right click and say create data shortcuts. That brings up a window like this. We already have this data shortcut created, so everything's all checked and grayed out. But if you didn't already have this created, you just check what you want to bring in, you say OK, and then all the drawings that are associated with that data shortcut project, you can create those derefs. Derefs are data references. So anyways, that's something, a key thing that we're going to be working with, so I had to explain that a little bit, just so everybody's on the same page about data shortcutting. We haven't
had John?
Yep.
There's a data shortcut training in that CAD video training folder already.
Yep.
So if people still have questions, they can go back there.
Right, yeah. Thank you, Mike. And yeah, we haven't done a data shortcut training in this series, but like Mike said, we have a data shortcut training video. I'll show you where that is real quick. So if you go to our training, our videos, CAD videos, and in one of these, here you go, data shortcuts. Mike has created a data shortcuts video for us that kind of explains how to set up data shortcuts. So anyways, we've got our surf E. We're assuming that's all good. I'm not going to save that. Don't worry about it because it's not going to change. So now we're onto our align file, and I've got some things that I did in this align file in order to create the corridor that we're going to go to later. So the first step that I did was I data referenced the surf E, which let's just go ahead and delete the surf E from this drawing. So I'm over here in the tool space. I work mostly through the tool space when I'm doing C3D stuff. I don't know why, I just find that the easiest. So select. So I'm going to select that surface, which it doesn't actually, I don't have that surface displayed, but when I select it through the tool space, I don't even need to be able to see it in order to select it. So I brought over my properties so you can see that my selection set has a tin surface. I'm going to go ahead and delete that so I can recreate the data shortcut here. So if I go to surfaces in my data shortcuts list and I create a reference to that surface, now it brings up another window over here where I can choose style and all that stuff. I usually set everything to no display because I don't really like to have my screen cluttered. So you can choose whatever style you want. It really doesn't matter because this stuff isn't going to get into production. I never reference the align file. I know a lot of people do, but I always deref all that stuff in to drawings just because I find it's cleaner, and I like to control things individually on each sheet most of the time. So I will go ahead and say OK, and now that surface is in there. And actually, did that mess anything up? No. Okay. So anyways, that's the dereffing the surf E. I created this alignment, which we already know how to do. I created a surface profile, which again, we already know how to do. The surface profile is pulling the existing surface information from the center line right here. The center line is represented by this green alignment. The other brown alignment that you see over there, or brown line, that's a no plot alignment that I'll get into later, but that's an offset alignment for a edge of pavement. So one thing that I do that is a good practice is that when you get into a project that has a ton of center lines and profiles and all that stuff, you're going to want to use a naming system that is logical and easy and short, so that when you're controlling all your targets through your corridor, you don't have a list of 10,000 words to sort through. You want things as short and simple as possible. So I have two center line alignments shown in this profile right here. Let me bring up my properties window again. And so what I'll do usually when I'm naming these, so when it comes up with a name on its own, it kind of like automatically generates a bunch of nonsense, and it's a pain to read through, and it doesn't really make a whole lot of sense. So generally what I will rename it is either the surface name, if it's easy to identify, or usually what I'll actually do is I'll just say exist EOP left. So that tells me that that is an existing surface, which I want to see exist first, just so that there's absolutely no confusion when you're bringing shortcuts in as to what's a proposed or an existing profile. That's the first priority for me. So exist EOP edge of pavement left, and I don't know how anyone could confuse that. So whether it's my system or you walk into this drawing 3 years later trying to figure out what I did, it's a pretty simple thing to understand when you read that description what that profile is. So use a simple, logical, and short description for each profile, and do not use the default naming scheme because again, it's nonsense, and you will get absolutely lost when you have 60 different profiles to target. So any questions on what I'm doing so far? I forgot to mention, if you have any questions at any point and I'm just blasting through this stuff, feel free to ask or stop me, tell me to slow down on anything, because I know that I am just blowing straight through this stuff. So I created a new profile, and these profiles don't make any sense. I just kind of drew some random lines up here and created some curves just so we can see a little bit of difference in what the vertical curves do when you're creating surfaces and corridors and all that. But they're just fun stuff. So after I created these profiles, I created data shortcuts for the alignments and for the profiles. So when you create a data shortcut for an alignment, actually, let's just go ahead and go in here to create data shortcuts. So this menu, when you bring up an alignment, you will have, I guess, a root alignment and then all the profiles that are associated with that alignment. So in this particular drawing, that road, which is my road, the center line, it has 4 different profiles associated with it. It's got the 2 existing profiles that you see here, and it's also got 2 proposed profiles that you see over there in my little blank space in the drawing. So the center lines for each and the edge of pavement left for each. For my offset alignment, I also have a profile, because the way that I set this up in the first place was you have to cut a profile for your offset alignment, and then I superimpose that onto the center line alignment. So I don't bother to create data shortcuts for my superimposed profiles because I'm never going to use those the way that at least Roadway does things. We always superimpose everything onto the center line. So you don't need I created a shortcut for the alignment itself, but you don't need to bring profiles along with it if you don't want to. So in this case, to keep my data shortcut list a little shorter, I did not bring the profiles. Another thing to note here in the organization of what I've done is that I have a centerline alignment section and I have an offset alignment. So this edge of pavement left is not a construction centerline. All it's used for is a design purpose. Let's cancel out of here so I can explain this a little better. So all these different alignment types here that I'm highlighting in the prospector of the tool space, you can specify when you create an alignment that it's an offset or a curb radius, rail alignment, all these other things. In general, I like to throw everything that is not a center line, like a construction center line, onto offsets. And so this list can house everything that isn't my main construction center line, and then it makes it just a lot easier organizationally to keep things straight when you got 50 different alignments floating out there for all sorts of different purposes. All right, take a breath. Take a breath. So I've already done this, but I was going to walk through this, but it's just going to take too much time to walk through it. So I did it, and I'm just going to show this way and what my reasoning was when I did this. So I created a second alignment for the left edge of pavement. Let's attach the roadway just so you guys can see what I'm talking about here. Let's go to our training, technical training track, 2018, our job. All right, so I'm attaching the roadway. I don't care about this full path overlay, all that stuff right now. I'm not doing it right. Don't bug me about it, Joe. So the roadway here, I included a little intersection here, and I'll show you why in the corridor in a little while later. And I also created a little bit of a taper down here at the end so that we can use targets both vertically and horizontally in our corridor later. So these are the steps that I used when I created that alignment. So creating the left edge of pavement, then I superimposed it, kind of already talked about this a little bit, created data shortcuts for both, and then I apply all that stuff to the corridor. That being the corridor, the surface, and you will have a finish grade and you'll have a datum generated by your corridor. And then I also have sections and stuff in there too. So let's just jump into the corridor real quick to see what that looks like, and we can actually get to the point of the training now that we have a little bit of background on what's going on. So corridors are controlled by alignments, profiles, surfaces, and assemblies. This is an assembly. The way that I generated these assemblies here was through the tool palettes. So if you open up your tool palette, which is this guy up here, it's also, you can press Control 3, or you can press this little icon on the ribbon, or however else you want to open up your tool palette. You have to go to the Civil Imperial Assemblies palette in order to access the features that I'm looking at right here. I just went ahead and used this primary road full section assembly. In general, I don't ever use these pre-built assemblies because I find them lacking in some ways, so I will build assemblies off of the other components. So if you've got, usually I'll start with a null assembly, and then I'll build with either basic shapes or lanes or curbs, medians. All these other pieces are sub-assemblies that you can add once to an assembly, and it will generate a corridor off of that stuff. So let's take a look at this. What I mean by saying an assembly is this little green line right here. That's kind of like your 0 point for an assembly, and everything that you attach, all the sub-assemblies that you attach to this little green line will build off of that. And then when you tell an assembly to generate a corridor, this center point of the assembly, this blue circle here, will target the centerline profile and alignment of whatever you're targeting, and it will just blast that corridor straight through. And then depending on what other horizontal and vertical targets you have, it'll shape the corridor according to that. But in the case that you don't have any other targets, it'll just blast it straight through. So that is what an assembly looks like. So if I click on what I did to generate this primary road full section, it shows a little green assembly line there. It's behind my white crosshair, so you can't really see it. But as soon as I click, it will place this assembly that I have selected. So I don't really want another one of those. So I'll show you what I did to this one. So I used the pre-built primary road full section assembly, which is this guy that I showed. I changed the lane widths because my road wasn't, it defaulted to a 12-foot lane width plus the curb, and I drew my road a little bit differently. So I had 30 feet to the face in the left lane, and I had 18 feet to the face in the right lane. And the reason why these numbers say 28.58 and 16.58 instead of 30 and 18, like I just mentioned, is that you have to account for the width of the gutter in that, and the gutter is 1.42 feet wide. And you can control all that stuff, all these dimensions, like how wide the gutter is, by going into the subassembly properties. And the way that I changed the lane width, for instance, let's just show you that one. I selected the lane, and then in the properties window, there's a width category. I can also control slope, I can control all the section depths, the name of it, and I will get to that in a second. You can control all sorts of things through properties window. A couple of things that you can't control through this window are a bit of a pain. You can't control the side, for instance. Like, so if I try to click this right here, it won't let me because it's grayed out. So in order to change that and to flip it, I would have to go to subassembly properties, parameters, and then change the side this way to left. And say OK, and then now my pavement flips. I don't actually want to do that, obviously, because I've already got a pavement on the left there. But that's how you would change those options if you can't access it through the properties window. I would recommend changing all the properties through the properties window rather than all the ones that you can through the properties window, because it's much quicker and easier. If you have to go into the subassembly editor, then you can, but I would use that as a last resort. Try to change things through the properties first, because it's just a lot easier. And you can do things globally. Like, let's say, for instance, that I wanted to select all the pavement sections. I'll select similar, and oops, that selected all subassemblies. So let's select just the pavement sections. If I want to change the pavement 1 depth to 6 inches, and I want to change the pavement 2 depth to 0, and I want to change the sub-base depth to 0, it'll change all that stuff globally. If you did that through the subassembly editor, you would have to do every single one by one, and it's just a pain that you don't want to deal with. Anybody got any questions right now? All right, so the next thing is organizationally, corridors can be a nightmare if you don't use logical naming systems and things that make sense. So the reason why, we'll get into that a little bit later once I go into the properties, but there are a ton of different text fields, and I don't think Civil 3D does a very good job of managing this stuff in a very concise way. So keeping your naming systems reasonable is very, very important. So when let's place I'm going to place a primary road full section assembly again, just to show you what the default names look like. So I'm looking over here in my properties window when I select this, and this is the name that it gives: lane super elevation AOR dash right, or in parentheses and then parentheses 9. That is a nightmare when you're going through all the targeting systems in the corridor properties. You don't want to deal with that. You don't need a naming system like that for any subassembly. So you are going to want to rename all of your subassembly components to something that is a lot more readable. So I call all my pavement right, pavement left, and it's the same for each subassembly, because each subassembly is managed differently. It doesn't matter if you have 6 assemblies, if you have a left pavement section on each one, you can name them all pavement left. It doesn't really matter, and it's pretty easy to keep it straight that way through the corridor properties, even if they have the same names, and I'll show you why later. So this one I just named curb right because that's what it is. It's the curb right. And this is daylight right. Same thing on the left, it's daylight left. So use a logical naming system that's simple for anybody to understand, because you will not be the only person that works on this corridor. So even if another person has a different naming system than what I'm using right here, they would still be able to understand what this is just by selecting it or by seeing it in the corridor properties list. So renaming all your subassemblies, that was the next thing that I did. Another thing that I did, because I created this intersection here, if I were to blast the corridor straight through this, then I would have a bunch of grading in this area that isn't really realistic to what's built. So typically what we'll do for intersections is I will create a different assembly that lacks all of the outside subassemblies. So I'll cut it at the edge of pavement, and I won't actually have anything beyond that. So that's what I did with this second assembly, is it's exactly the same as the first assembly, except for it doesn't have the curb, and it doesn't have the grading outside the curb. So let's just, the way that I did this, we'll get into corridor properties here, I guess now, so I can explain this. So when you create a corridor, you're gonna have one region. These three sections right here that I'm going back and forth through, these are what they're called regions. So when you create a blank corridor, unless you set it up that way, I mean, it'll ask you how many regions you want to create, and in general, you're just going to create one right at the start, and then you're going to delineate things a little differently as you go on and as the design progresses. So when I started, I just had one region, and actually, let's just delete these regions just for fun. So I'm going to remove these, and this ends at 1914, I think. Sometimes this doesn't really like to cooperate. Let's just see. There we go. For whatever reason, it doesn't like 1914, even though 1914 is a real station in there. Again, Civil 3D is a little weird sometimes. So I'm going to go ahead and say OK, just so we can see what this looks like. And what happened was, all these lines that I'm highlighting right here weren't there before because I had my region splitting this all up. So that the corridor wasn't actually generating any feature lines here. So yeah, the reason I did that is because all these intersections I generally like to control with feature lines individually rather than using corridor generated feature lines, because you can do it with corridors and alignments, you can do intersections that way, but it's more complicated than it's worth. In general, it's easier to piece corridors together. Like say there was a road that continued up to the north here. It's easier to piece corridors together through feature lines than it is to use the actual built-in intersection tools that Civil 3D has. Civil 3D is just not very good at that. So just doing some feature lines for back of curb, face of curb, edge of pavement, that's the way I would approach things. So I'm going to go ahead and I don't know if I can undo that. Let's see if I can. I don't think I can. Oh, I can. Yes. All right, great.
So, John, just a little tip. If you guys are undoing, just be aware that it might crash on you. Undo sometimes leads to a lot of bad things. So.
Yeah. Well, if you don't want to crash, use MicroStation. That's the #1 tip. We're using the wrong program if we want to avoid crashes. That's my little transpo jab at everybody else for the day. All right. Where was I? I was on that intersection and how I created this subassembly, the second subassembly, in order to kind of model that intersection. And we covered how to split the regions. So we broke the regions here. And, creating the FG surface from the corridor. So let's go to I'm looking at my tool space right now. The way that you create a surface, I'm going to go, you can access corridor properties a lot of ways. I'm going to work through the tool space because I just find that's easiest for me. So I'm going to the properties here of that road corridor, which is the corridor we're working with. And there's a tab up here called surfaces. So this is where we're going to generate our surfaces. And I'm just going to create a couple of new ones. These ones that I've already created are what you're showing, or is showing up in the screen that you're looking at on the left. But in order to create one, if you hover over these guys, it'll show you what they're going to do, these icons. So create a corridor from surfaces, the far left one, that's the one that we're going to want to use. This one uses links, and I don't even know what this guy does. Surface name template, I'm really not sure. This left icon here, that's the one that you're going to want to use. This just creates a surface. So once you create a surface, it doesn't actually have anything in it yet. You need to tell it what to do. So you can give it a name. It doesn't really matter what the name is. I'll just do new surface. And then you specify what codes you want to use for that surface creation. So what this code thing means is it's picking points in the corridor. Each of those corridor nodes has a point code associated with it, or like a shape code and stuff like that. So it's picking whatever point you're specifying right here in order to create that surface. In general, from these corridors, we're going to create an FG and we're going to create a datum. So when you create an FG, you want to use the top code because that'll pick the top links for every single component that you're dealing with. So you also want to specify the overhang correction top links for anything that's on top. So for the datum, you want to do the same thing. The datum and the FG have to be separate surfaces because they're two different things. So the datum will use the datum code, which should specify that it'll go to the bottom links for each of those things. But again, for the overhang correction, you want to also click bottom links. So this is going to be our new datum. And there we go. That would create two new surfaces, and I'll see that in my tool space here when I open up my surface list, that now new surface and new datum are two surfaces that I just added. They'll be identical to what I've already created for the FG and for the whatever else, the other datum that I was dealing with. So let's actually, I don't really care if they're there or not. Which one am I selecting? Okay, good. No display. All right, let's go over to my list to show what I'm doing here. So we created an FG surface from the corridor, and now I want to show you how to pull polylines from the corridor to generate a surface boundary. So I already have a surface boundary in here, but let's just say I deleted this, so it's gone. This corridor is going to try to draw some triangles in unreasonable places that you're not going to want. And so if you look closer at the corridor itself, so I'll turn on the line weight so you can kind of see. These brown lines, the thicker brown lines, are the actual corridor feature lines that are generating this corridor in this model. You want the surface to end there. So if you want to select those polylines, the easiest way to do it is to select whichever line you want to pull from the corridor. You open up this. That'll open up a context-sensitive window on your ribbon. Let's get rid of some of these things so you guys can see more of my screen. So first off, I'm here at the Home tab. When I click on the corridor, it'll open up a different tab specifically for this corridor. I open up this Launchpad and say Polyline from Corridor, and it'll ask me through a dialog box, since there are two different feature lines at that point, which one I want to use. In this case, both of those are identical. If you have two feature lines on top of each other, like maybe a wall or something like that, then you may need to be a little more careful about which one you select, but in this case, it's not going to matter which one I do. So I'm just going to say OK on that, and it'll pull in a 3D polyline on whatever layer you have active. And I have def points active right now, so that's why it came up white. So that leaves the command active. So if I click on this line now, again, the same thing will come up where I select that line. So now I've got both those outside lines, and now I'm going to select this guy as well. And I'll just use daylight again. Now I've got a pretty good outside boundary, or a pretty good idea of what I want from my outside boundary. I'm also going to grab this line right here. There we go. And I'm going to select these lines and just drag them off into space. So when I drag things off into space to edit,
So does that show all the proposed development?
here, 1 second. Hey, just so you guys know, you can do this. So right now, somebody is unmuted, and so I will just go ahead and mute. Anybody can do that. Like if you wanted to right now, you can mute me, but don't, please. So anyways, I drag these things off into space into, oh, now I'm freezing. Okay. Just some direction. So usually I'll go straight up. I've always got my polar tracking on, so I can just go straight 90 degrees very easily, and I'll just drag this stuff off 2,222 feet. So I just press 2 4 times, and then bam, there's my line I just drew. So anyways, this surface, I'm going to need to connect it here in order to kind of model my intersection, and I'm going to trim a little bit up just to clean this up a tiny bit. I'm going to connect the ends. And then I'm going to explode all this stuff. The reason why I need to explode is because this stuff got brought in as a 3D polyline, and that's not going to work well for a boundary. So you want to get it to a line, and then you also want to flatten all this stuff.
Hey,
so I
just to stop you there, John, right away. Under the modify, under modify design.
Mm-hmm.
convert 3D to 2D, and then
Mhm.
you could change it to 0 elevation. Same thing, just different way to do it.
Yep. Thank you. So now I'm going to poly join those things back up so it's all one shape. And that should be all nice and closed. So I'm going to go ahead and move that back down to where it was. And then I'm going to regen so I can see it. And I'm going to add this to the surface for a boundary. And the way that I'm going to do that, I'm going to open up my tool space again. And I want to apply this boundary to both the datum and the FG. So I'm going to do that right now. You just add a boundary. That'll bring up this menu right here. Doesn't really matter what you name it. You can name it if you want. You can leave it blank if you want. It really does not matter. I just use a non-destructive break line for all these corridor models. So go ahead and say OK. That'll add that to the datum like I specified. Oh, actually, sorry, I didn't have the line selected. So there it is. Now it's added. And definition boundary add. Doesn't matter if you name it. Again, I'm going to add a non-destructive break line. Click on that line again. And now my surface is what it was shown as before. Another thing to do, don't leave this on def points. Move it to like C10 boundary or something. And that's that for the boundary. So the next thing to do, creating sample lines. This is again another thing that could take a long time, but I'm just going to blast right through it. So I already have these sample lines created. The way that you create them is you just go up here in the Home tab under or above Profile and Section Views, click on Sample Lines. That'll ask you to select an alignment. You go and select that alignment, and then you create by range of stations. And you pick whatever stations you want as your start and end. And you control the swath width, which is how far it goes from the center line in each direction. So for on the left, pick your dimension. I'm going to go 120 or whatever, and then go 120 again on the right, or you can change it. Yeah, I can go 120 on the left and only go 70 on the right. It really doesn't matter. All these increments are how often it samples. So how many, like how the distance in feet between each sample line along the center line. And then you can also specify whether you want to start at the range start or end to draw a line there or not. Default is false. I usually change that to true just so I can see what it's like at the very beginning and the very end. Horizontal and blah, 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 all that stuff. You don't really care. Again, that would take too much time to explain all those details, but if you do have any questions, go ahead and feel free to ask. And then you create cross sections, which that's very easy as well. Up here in the same section, Profile and Section Views, expand Section Views, and create multiple views is the thing to select here. So this will bring you to this menu. You can just go ahead and say next on that. You don't really need to change anything unless you've got multiple corridors and alignments and stuff like that. Then you may need to specify something different. But in this case, we've only got one, so there's only one thing to do is just press next. So production, you're not going to want to use that option. That's going to try to create other drawings based on templates and stuff. Just, yeah, don't do that one. Do draft, and then select the new group plot style. It's just a lot cleaner than the standard one. This is a Dibble custom dealio. So anyways, now if you press create section views, it will generate what I've got here off wherever I click. So this that we're looking at right here that I just created is identical to what I already had. One thing I will note about all these things that I've got out in space, pick something reasonable for where you're placing these things. I'm a little more particular about this than most people are, but like for instance, when I drew this assemblies box, I didn't just randomly pick that spot. If I open up my properties window, the X and Y vertex for that are 2500 and 1500. And then I just drew a rectangle that is, I think, 250 feet wide by, let's see how tall it is, 500 feet tall. Same thing over here. I picked a even numbered XY location, and I drew this a sensible dimension, so that's 1500 feet, and this is 750 feet tall. So like all these things, all these shapes that you're looking at that are floating out in space, they're not just floating randomly. And these two lines are actually level with each other as well, if you look at that. Try to keep things clean is basically the motto here. You don't need to be as particular as me, but just at least make it somewhat organized, because this is a lot friendlier to look at than when stuff is just floating out in random places and you got an assembly here and then you've got an assembly down here and then another one over in that direction. Just keep things simple. All right. So I've created the cross sections, And what you're going to want to do with cross sections, or one thing you might want to do, is to compute materials. That is through the Analyze tab. If you press Compute Materials, the first time you do this, you're going to have to specify what your EG is and what your datum is. We've already created those surfaces, so it should be pretty easy to just select those through a drop-down. You don't need to worry about selecting anything for the corridor. But anyways, when we say OK to this, it'll bring up a materials list. The materials list that it generates by default is generally correct. The ground removed will be called cut, and the ground fill will be called fill. And the only thing that you have to change in this menu here is the condition. So for the NG and the datum, it's just calculating the difference between those two surfaces, the volume between those two surfaces. For ground removed, you obviously want stuff that's below the natural grade and above the datum. And for fill, you want stuff that's above the natural grade and below the datum. You can control all these fill factors and all this stuff. Generally, we're just going to calculate things one-to-one. But if you need to, you can specify different things for those factors to compute your materials a little more accurately. So you can modify the sections in these the styles in these cross sections. Let's just show you real simply how to do that. I'm trying to blast through, so I'm going to try to wrap up in like 5 minutes here, Joe. So through the sample line group properties, that's where all this is controlled. This is another one of those AutoCAD things I don't understand why they organize it this way, but they do. Doesn't really make any sense that it's here, but it is. So I created custom styles for the cut and fill because by default they're just going to be standard. So if I show you what standard looks like. Okay. So, I actually changed standard by default. So let's show you that actually, how I did that first. So if I go to the assembly properties, I'm clicking on assembly and I go to assembly properties here. And I'm going to go to codes and edit the codes. I just clicked on the little pencil guy to edit these codes. So the shape codes are what control how everything looks in your cross sections and all that stuff. So I'm clicking on standard here in order to modify these shape styles. So you have 4 different options for your views. You have a plan view, which is what I'm looking at right now on the screen in this view over here. And then the section view is the other one that's going to matter for us in this because we're dealing with sections. So I turned off the border and the area fill for the standard style. But if I turn that back on, you can see what it looks like by default. It'll basically look like what this default assembly looks like. Everything gets filled in with orange. And that's ugly, and it'll print terrible because it's all just going to be black. So we don't want to do that. Let's go back into the assembly properties, codes, pencil guy, and let's modify that standard to be in section view invisible. And there we go. Now if we go back to our sections, we will see that it doesn't plot that way. So when I created those custom cut fill styles in the sample line group properties, I changed these back to standard, but now I'm going to change it back to the cut and fill styles that I created. You can. This is just a way to visualize. It helps visualize a little better in the section view what is cut and what is fill, obviously. So right here we're seeing that this is below the existing grade, which is shown up as this red dashed line, and this little crosshatch area, that's our fill, which is below the FG there. Or below the datum, actually. So, I'm going to modify styles and cross sections. Already did that. Create styles for cut and fill. Already did that. I didn't actually show you how I created them. It's pretty easy. Same thing what I was doing before. I'm going to the sample line group properties, and if I click on these styles, it'll bring up this pick selection style menu. So I'm going to just click the pencil guy. The pencil guy is what you want to do. And same 4 options for the view show up here. If you just click on section, because that's the style you want to change, then you can control the area fill through this. The shape fill or shape area fill, you can pick whatever you want. So if I want that to be instead of the crosshatch that I did, you know, if I can use anything. So let's just, I don't know, use a concrete hatch for whatever reason. And I can change the scale of that. Let's make this real small, like 0.5 or something. See how small that looks. Go ahead and say OK. And now if I go back over to the sections and look at my fill, I've got a concrete hatch for my fill. That's all there is to that. I know I'm blazing through this stuff. One last thing I wanted to show you guys is that the corridors by default may not select a accuracy interval that you're going to want. Actually, there's two more things I wanted to show, sorry. So if I go to the corridor properties, the parameters tab is where you're going to spend a lot of your time. So frequency right here, I've already got this set to 10, which is pretty frequent. You're never really going to want to go more than that, but generally it's going to start at like 25 as a frequency. Let's just change all this stuff back to 25. So if I click that top three dots, it's going to bring me to the global properties for the whole corridor. So I'm going to change these values to 25. And apply that. You're going to see that those brown lines across the center line get spaced further apart. And if I go ahead and look at the surface, you'll probably notice as well that in a lot of places it gets a little wonky because it's not sampling as often. So I like to have my frequency, the target frequency, as high as I can while Civil 3D can handle it. So if you've got a very, very large corridor, sometimes it gets a little tough to be a whole lot more frequent than like 10 feet. But we're just going to leave it at 10 for now. Okay, I'm going to go back into my corridor properties real quick and show you what I did for the horizontal and vertical targeting. So again, these top three dots control the entire corridor. So if I click on those top three dots, it will give me the region codes and stuff for every single region. And it doesn't really give you a good idea of what's what, because all these things are just kind of a bunch of nonsense. And this is why it's important to name things logically, because if I see daylight left, daylight right, and all this stuff, it's easy to understand. Whereas if I left it in the default forms where it's 50 characters long and a whole bunch of codes, you don't really know what's going on. So this is, again, why it's important to keep things logical. And if you have something, just name things the same. That's all. So in this instance, I know my taper is in my third region, the one towards the end. So I'm going to go ahead and open up that region only so I can modify that one. So by default, you're not going to have an offset target or a vertical target. So I'm going to go ahead and delete the ones that I have just so I can re-add them. And I'll show you what it looks like when those things are deleted. So after deleting those and rebuilding my corridor, actually the corridor already rebuilt itself. So if I look down here, my roadway base is now not in agreement with the corridor. And you can tell the surface is all messed up and stuff too. It's because my corridor is not actually targeting the edge of pavement here. So this brown line that I have selected is the alignment for the edge of pavement. So if I actually want to control that vertically and horizontally, it's easy to do through the corridor properties. So I'm just going to select the corridor, go to properties, parameters for the third region. I'm going to target for, we know this is on the left side. It's on the left side of the center line. So on the left, I'm going to target the edge of pavement left and add. You can target alignments. Here, by the way, you can target alignments, or you can do feature lines, survey, figures, and polylines. You can do different things if you want. In general, I pretty much always try to use an alignment rather than any feature lines or polylines. But there are instances where you may want to control it with feature lines instead of alignments. Anyways, so I've got this added, this horizontal target, and now I want to do a slope or elevation target for, again, the pavement left. So that brings up this menu. Here we can do the same thing, profiles or feature lines, survey figure lines, and 3D polylines. In this case, I'm going to leave it a profile since I've already got that profile created. We know that my root center line for that profile is that road, and the profile that I want to target for this edge of pavement left is the edge of pavement left. So if I say OK on both of those, it's going to rebuild the corridor, and you just saw that snap back into where it should be all along. So that is a really, really, really basic and fast look at what corridors can be used for and what they can do. And I'd like to open the floor for a second to anybody who might have any questions. Let's take a look at my dog while we're thinking about questions.
Hey, John.
Yep.
So in the past, one of the projects I worked on in Transpo, I had to modify the alignment after I set up the corridor, and it was a pain to go back and modify the corridor. How would you go about doing that? And can you give an example?
Yeah, sure. That's a good question. So when you modify, so all these drawings. So I'm working in an align file, a core file. Those are my two main C3D type files, the ones with dynamic elements. But let's just say that in my align file here, I'm going to detach the roadway so I can see my alignment better. But let's just say that the left edge of pavement went like this instead of where it was before. So I'm going to save that so that it actually changes in the align. If I go back to the core, then it'll ask me to synchronize. So if I synchronize and the corridor rebuilds itself, which it's not going to rebuild itself automatically. I'm going to go back to my tool space, which is now not showing up. Here we go. If I rebuild the corridor, it should snap right to that horizontally. And same thing with the profile. If I had modified the profile, I would have to synchronize if it's a cross drawing. Some people like to throw this stuff in the same drawing. In general, I find that it's not worth the extra space that it requires per drawing to keep all this stuff in the same place. So in the align file, you're going to want to have, I always throw any alignment. It doesn't matter what it is. If it's an alignment, it goes in the align file, because if I'm working in someone else's job and if I want to try to find an alignment, that's the first place I'm going to look. I'm going to look in the align file. So why would I be looking in the core file for an alignment? It doesn't make sense. So I throw any alignment in the align file. The only time that I ever condone combining C3D elements is I like to put any profile with its associated alignment, and that's because the dynamic links between those don't work very well across drawings. Things break, and Civil 3D just does not handle it well. So if you have a separate prof drawing from your align drawing, then things will go wonky and you won't be happy. So I always keep profiles in the align file. That's the only time I combine things. So otherwise you'd have to synchronize across drawings when things get updated. Does that answer the question pretty well, or were you thinking about something else?
No, that's perfect. Cool. Thanks, John.
Yep. Anybody else? I know I absolutely blasted through that. Most people probably don't have a very specific use for a lot of the stuff that we're doing. So that's kind of why I wasn't really that concerned with covering all the minute details, because most people honestly don't really use corridors. But if you do happen to use corridors, or you find yourself in need of using them in the future, and you've got any specific design questions, definitely feel free to ask. Sorry if I blew right past things in a way that was too quick to understand, but there's a lot to it. This takes a long time to master, and I'm not even sure anybody really ever does master it completely. So yeah, sorry, there's a ton of information to cover. I hope I did an adequate job, and let's hand it over to Joe. So I'm going to stop sharing my screen, and Joe should take over from here. Thanks.
All right, I'm going to make this pretty quick because we don't have much time left. Can you guys see it? Yes. All right, so Subassembly Composer, it is a similar tool as to what John was using, except for you can control a lot of these different things that John had issues with. I would say that Subassembly Composer is not something you'd want to use for every single assembly, but it is something to be able to make something more specific. For an example, I created one in our practice, we have a document called an AC that basically tells us how we have to grade pavements and everything regarding to taxiways. So created different little ways of organizing that. So let's just jump back to a new blank. All right, so here we go. This basically lets you draw your different shapes. This here is a little bit more difficult. I would say if you're just starting from scratch, probably don't use this unless you have to. And then auxiliary it'll find a point. Once again, a little more difficult, so it'll help you find out whether you're in cut or fill, stuff like that. This helps you just organize, and this bottom part, I don't use it often, so we'll just skip it for now since we don't have time. So, for some examples of organization, we have this monster here. These three different shapes here are created by all this. The